Now I request the respected principal, Dr. Shivakumar, to introduce the chief guest, Dr. V.K. Saraswat, and invite him for the graduation day address.
I am very happy to introduce our respected chief guest, Dr. V.K. Saraswat ji. Vijay Kumar Saraswat was born in 1949 and completed his bachelor's in engineering from Madhav Institute of Technology and Science, Gwalior. Completed his M.Tech from Indian Institute of Science, Bangalore, and obtained doctorate in propulsion engineering from Osmania University, Hyderabad. Dr. Saraswat, a PhD in combustion engineering, started his career in DRDO in 1972 at the Defence Research and Development Laboratory DRDL, Hyderabad, and was responsible for the development of country's first liquid propulsion engine, Devil. As project director of Prithvi, he stayed the design, development, production and induction of the first indigenous surface-to-surface missile system into the armed forces. As program director, Air Defence, Dr. Saraswat pioneered the concept of theatre defence system and integration of national air defence elements. He was the director, Research Center, RCI. He was the director, RCI, Hyderabad before taking over as CCR&D in November 2005. He established facilities for design, production and testing of engines and the RCCs of technologies for the missile applications. Under the able leadership of Dr. Saraswat, India has embarked on a challenging futuristic air defence program encompassing development of complex anti-ballistic missile systems, radars, C-41 systems and integration of battle management resources into a national authority. As Director RCI Hyderabad, he conceptualized and established facilities for development of micro and nano sensor for future avionics. Dr. Saraswat is presently serving as the Director General of the Defence Research and Development Organization, Secretary of Defence Research and Development, and the Chief Scientific Advisor to the Minister of Defence. Honours. Dr. Saraswat has many honours to his credits. Dr. Saraswat is a Fellow of National Academy of Engineering, Aeronautical Society of India, Astronautical Society of India and Institution of Engineers. He is a member of Board of Research of AICTE, CSIR Labs and Board of Studies of Osmania University, Hyderabad. He is the Chairman, Combustion Institute, Indian Section and Aeronautical Society of India, Hyderabad branch. Dr. Saraswat is the recipient of DRDO Scientist of the Year Award for 1987, National Aeronautical Prize for the year 1993, DRDO Technology Transfer Award 1996, Performance Excellence Award for the year 1999. For his outstanding contributions to the nation, Dr. Saraswat has been conferred with Padma Shri in 1998. May I request respected Dr. V.K. Saraswat ji to deliver the graduation day address.
Namaskara. Good afternoon to everybody. Respected Dr. Shri Shivakumar Swamiji, Shri Siddhalinga Swamiji, Dr. Rudraya, Chairman, Siddhalinga Institute of Technology, Principal, Director, Faculty, esteemed guests and invitees, electronic and print media, parents and my dear young graduates. I stand humbled and delighted to be among you, students, the future of India. Today is another milestone day in the history of Siddhalinga Institute and particularly for the graduating students. We joyously celebrate a key milestone in our lives in the fine company of friends, family members, peers, honored guests and staff of the Institute. I congratulate you on your accomplishments and conducting what is a part of your life's academic journey. I hope your education and learning at Siddhaganga Institute will serve you well in your professional and personal endeavors. You are all most lucky to have been born and brought up in an era where our nation is surging forward in all walks of life in an unprecedented manner. The knowledge that you have gained and the myriad opportunities and the options that you have afford you the freedom to choose your area of interest, a luxury which many of your forerunners did not have so early in their life. I feel so happy for you. You are empowered by knowledge and now have to fortify it with your personal qualities like honesty, hard work, sincerity and integrity to top it all. With a sense of pride to serve the nation, I am quite confident that you will have the most rewarding experience in the years to come. Our country has produced great visionaries and personalities like Jawaharlal Nehru, the visionary of modern India, Homi Bhabha, the pioneer of nuclear energy, Dr. M.S. Swaminathan, the father of the Green Revolution in India, Vikram Sarabhai, the architect of India's research in space, Dr. Abdul Kalam, the proponent of a developed India, and Dr. Kurian, the vanguard of the White Revolution, and many more. May the vision of these great leaders serve as a beacon light in the course of your academic voyage, giving you the direction that you seek. My dear young minds, on the graduation day, I would like to share with you some thoughts which have evolved by virtue of my long association with great visionaries of this country and by being part of a dynamic organization which is working for India's technological self-reliance in the field of defense. I would consider these moments with you worthwhile if I could present to you the technological challenges lying ahead of us and thereby inspire you to identify areas of your own strength and interest and those of people around you in the endeavor of making our nation a great technology leader. If we take stock of growth of technology on a time scale over the centuries and understand its human impact by means of its consequences, we will realize that we have to give equal importance to each and every segment of technology for the security and well-being of our mighty nation. Be it national security, energy security, space security, economic security and growth, biodiversity, environment, living standards which include food security and healthcare. And each one of these hinges on the basic premise of knowledge economy with sustainability. I would like to dwell upon sustainability, which implies meeting current human needs while preserving the environment and natural resources needed by our future generations. The perceptions of sustainability vary across regions and nations. However, as part of a broad agreement, the goals of sustainability to foster a transition towards development paths and meet human needs while preserving the Earth's life support systems and alleviating hunger and poverty. That is, sustainability integrates the three pillars: environmental, social and economic pursuits. And I would like to add here that there is one more pillar which is important and which I learned this morning while being in the part of the seminar on capabilities, integration with science and spirituality and values. I feel that sustainability should add spirituality as a fourth pillar to ensure that those values, those core values which we nourish, which we have been inherited, become the pillar for maintaining sustainability in the world. In the wake of a host of changing technological, environmental, social and economic conditions, it is necessary that we should reorient ourselves from development to sustainable development. The role of science and technology in sustainable development is viewed in new way with emphasis on technologies for empowerment like education, information, communication, etc. and environmental sustainability like sustainable agriculture, clean and renewable energy, improved resource efficiency. The focus of technologies in sustainable development is whole system. Knowledge is strength is a well-known adage an irrefutable fact. The progress of a nation is quantified by its achievements in science and technology. We are ideally poised to become a knowledge power with a large resource of intellectuals, higher caliber academicians and scientists, a growing middle class who have assigned top priority to education, and a number of world-class institutes of learning and research. We have a critical mass of skilled manpower, especially in the field of science, and a well-functioning democracy. We have a large, impressive diaspora creating valuable knowledge linkages and networks, and above all, 540 million young youth. India should continue to leverage its strength to assume a leadership role and take on challenge to build new and resurgent India. Here I would like to quote what our Honorable Prime Minister Dr. Manmohan Singh has said. To quote, "It is our scientific capabilities that will determine our ability to overcome challenges which lie ahead in areas such as climate change, clean energy, environment-friendly technologies, water management, affordable health care, food security and biotechnology. Solutions must be found in timely manner and then must move out of the laboratory quickly and find wider acceptance." Let me take some of these security issues, and I'll start with energy security. To quote Dr. Homi Bhabha, he said, "There is no power as costly as no power." What a quote. Energy is the engine for social and economic growth. It multiplies human labor and increases productivity in agriculture, industry, as well as services. To sustain growth rate in economy, energy supply has to grow in tandem. To give you an idea, 1% GDP growth rate requires about 0.7 to 0.85% of energy growth rate. There are countries where people talk of women education and energy consumption as an indicator for developed nation. We should look at ourselves and see where do we stand. Until recently, the sources of energy were dictated by their availability and accessibility, its economic viability and the conveniences. Coal, oil and natural gases remain as the main source due to high and wide availability, about 80% of the world's total energy supply. As you are aware, the main problem with these sources is the human footprints it creates by the emission of greenhouse gases. For the past 35 years, greenhouse gas emissions have been increasing at a rate of about 1.6% per year. From now until 2030, assuming business as usual, carbon dioxide emissions are expected to increase by roughly 55%. According to international study, there will be an estimated rise in temperature of by about 1.8 degrees to 4 degrees Celsius during 21st century due to the use of such fuels, leading to increased natural disasters and a classic case of construction destruction paradox. In this way, energy security is relevant not only to the economic security but also to personal and human security. The Indian energy resource position explains our strategy for deployment of a mix of energy sources to meet our immediate, midterm and long-term requirements. Let me present to you an interesting estimate. If the level of our per capita electricity consumption is raised to the level of a developed country, which is about 5,000 kilowatt hour per person per year, and only a single energy source is to be used, then our reserve will last as follows. Domestic extractable coal reserves will last for less than 13 years. Uranium, when used in the open cycle, will last for just about half a year. Uranium in closed cycle with fast breeder reactors will last for about 73 years. Known reserves for thorium in closed cycle with breeder reactor will last for about 250 years. Entire renewable energy, including hydroelectric capacity, will be sufficient for about 70 days per year. Total solar collection area based on MNE's numbers, which is about 20 megawatts per kilometer square, needed will be at least 31,000 square kilometers. So what are the solutions? If we want clean energy, there is an immediate solution. Research on producing clean energy by adopting technologies that do not emit carbon dioxide or by capturing the carbon dioxide emissions is very promising. Works in the area of carbon capture and storage to stabilize greenhouse gases in atmosphere through safe and permanent sequestration have already begun. Here carbon dioxide, which is directly captured from the industrial sources, is concentrated into a near pure form compressed into a supercritical fluid, and then pumped deep underground for long-term storage. Estimates indicate that about 99% of carbon dioxide will remain trapped for over thousands of years in well-selected areas. Clean coal technologies aim for a near zero emission by removing pollutants like sulfur dioxide, NOx, particulate matter, and greenhouse gases. Integrated gasification cycle, ultra supercritical combustion, oxy-fuel combustion are the emerging clean coal technologies that can form part of our research endeavors. Such endeavors require public-private collaboration that can construct many megawatts zero emission plants that will produce both electricity and hydrogen from coal while capturing and storing the carbon dioxide. There is a mid-term solution for this security. We as a knowledge nation must turn our full attention to renewable technology. The world over investment on renewable energy sources like solar, wind, ocean, tidal has picked up momentum in recent years. We must also respond to the challenge and take initiative to harness the resources available with us. The sun alone can supply 10,000 times more energy to planet Earth than what man is using today from fossil fuels. But what is needed is affordable solar power. India's energy consumption in the year 2009 was about 150 gigawatts and is expected to rise to 400 gigawatts per year by 2030. Our total renewables energy capacity from all sources is predicted to be 100 gigawatts. If we could utilize about 1% of our land area for harvesting solar energy, we could generate about 800 to 1000 gigawatts. That speaks of the immense potential in the field in our country. Here I would like to also mention to you that land-based solar plants are constrained by suitable location for abundant sunlight and also time of the year, daylight and so on. And a day might come where we could overcome this difficulty by a space solar power plant which could be harnessed 24 hours per day from the inexhaustible energy of the sun. The cherished aim of India's national solar mission is to establish India as a global leader in solar energy through an installed solar power generation capacity of about 20,000 megawatts by the year 2020, 100,000 megawatt by the year 2030, and 200,000 megawatt by the year 2050. There is a long-term solution which is nothing but nuclear energy. On its surface, nuclear energy satisfies many of the optimum requirements for enhancing energy security. Nuclear power produces virtually no sulfur dioxide, particulate nitrogen oxides, volatile organic compounds or greenhouse gases. Emits only about the complete cycle from resource extraction to waste disposal, emits only about 2 to 6 grams of carbon equivalent per kilowatt hour, which is about the same as wind and solar. But the management and disposal of spent fuel often referred to as the Achilles heel of the nuclear industry. But if we look closely, we can see the amount of spent nuclear fuel produced annually, about 10,000 tons, which is actually small when contrasted with 25 million tons of carbon waste from the fossil fuels that is released directly into the atmosphere. Many technological issues associated with geological disposal of high-level radioactive waste already have been addressed. Due to the limited reserves of uranium, as I mentioned, 73 years of closed cycle, nuclear energy based on thorium has a prominent component of Indian energy scenario. A number of ambitious nuclear energy programs are on the anvil and the future is bright for this sector. We have the largest number of reactors under construction compared to any country in the world today. This bodes well for our future energy needs. Our aim could therefore be to work on core areas like clean coal technology, nuclear and renewable sources, primarily solar and biomass and hydrogen in the immediate future to see its commercially viable application by the end of this decade, and an asymptotic growth of power generation capacity by these means in the next decade. I would like to see Siddhganga Institute of Technology play a lead role in this mission. Now I would like to touch upon the national security scenario. The means of fighting war have undergone changes through ages. The world has seen human warfare using primitive weapons, weapon warfare where arms and ammunition took major role, economic warfare where control of market forces are involved, and cyber warfare where a wargaming, modeling, simulation of systems, bugging, etc. are involved. Modern threat categories include weapons of mass destruction, missiles, battlefield threats like aircraft, submarines, surface ships, tanks, electronic warfare, information warfare, cyber warfare, space control and security, and low intensity conflict. Here we will have to analyze the global threat to India with respect to our nuclear doctrine, which is no first use and no use against non-nuclear states. Technology development for national security is the mandate of Defence Research and Development Organization, and its mission is to design, develop and lead to production the state-of-the-art defence systems and technologies, provide technological solutions to the services to optimize combat effectiveness, and develop infrastructure and committed quality manpower and build strong indigenous technology base. DRDO has already developed strategic missiles like Agni, Prithvi, BO5, tactical missiles like Akash, Nag, Astra and so on. Many electronic warfare systems and phaser radars have been developed and inducted. An armament discipline, induction of MBT Arjun, has made our country self-reliant in this vital area. Recent induction of INS Arihan, the nuclear power submarine, has propelled India in a select group of nations. Interception of ballistic missiles using high-speed interceptors, long-range radars, a robust C4I system has been a major breakthrough for our country. Light combat aircraft Tejas, the first stealth aircraft of its type, has come to advanced stage of induction. All these and many other success stories are shining examples of DRDO's collaborative mission mode approach to development of critical technologies and systems. But the technology in all these areas is galloping. With the advent of MEMS, nano and biotechnology, the size of systems is getting smaller, performance getting enhanced, and the cost is coming down. We have to mount many more R&D programs in collaboration with industry, academic institutions and national laboratories for development of nanosensors, structures, communication devices, computing systems. It is the convergence of bio, nano and information technologies that will make the future systems, platforms and weapons affordable, self-healing, robust, intelligent and globally competitive. The various terrorist attacks that we had in the past have raised new demands for technological need which differ from those for conventional warfare. We have made progress in developing systems for surveillance and reconnaissance, enhancing day and night vision capability, explosive and detection and diffusion, incapacitation, communication and jamming, personal protection, and in support systems like life detector, biomedical equipments and devices and products. The emerging scenario is that more and more use of space is being resorted to. Everything what we do is dependent on the availability of sensors in the space. So space security is becoming yet another major area. Space security is the basis for responsible use of space. Outer space should be free for exploration and used by all states. Major threats to space security are increasing amounts of orbital debris, increasing crowding in some key orbits, and potential use of space weapons that threaten the space environment. Crowded orbits increase possibility of spacecraft collisions. With the increased application of network-centric warfare, utilizing space assets of communication, navigation and surveillance, the case for space security is becoming very strong. An example of such a weapon is the space-based interceptor for missile defense, which has the potential to intercept missiles from rogue states. For kinetic energy, anti-satellite, a large number of technologies like booster, kill vehicles, weapon control systems, debris mitigation, launch support systems, engagement planning are big technology challenges. I invite all of you to join these programs and make our country self-reliant in the vital area of national security. Emerging threat is cyber security, with NCW and all of us using communication as the lifeline. With the advent of computer-based networks, internet and application-specific software operating systems, all connected on a grid for economic, commercial, defense, civil aviation, knowledge dispersion, education and strategic activities of the nation, the next age of war is going to be cyber warfare. In this, the weapons are going to be information denial and information espionage using modern software, hackers, worms, viruses, spoofs, etc. China has already made considerable progress in this regard. We as scientists and technologists have to develop information security systems as defensive actions and as cyber attack weapons to paralyze enemies' economic and security activities. And finally, the food and the health security, which is very important for a growing economy. The first green revolution became a reality with the availability of miracle wheat variety, land reforms and electricity provision to the farmers. And the triumvirate Dr. Swaminathan, Sri R. Venkatraman and Srimati Indira Gandhi provided the leadership for food self-sufficiency was a major achievement. At present, the way population grows at an annual rate of about 1.8 to 2.2%, and the dwindling of agriculture growth situation is bound to be alarming, if not the worst, by the next decade. The current growth rate in the agriculture sector is stagnating 2% during the last decade. Our country's food stock has not grown to cater to the needs, and the government has to undertake negotiations for the import of wheat. With no land to farm anymore and the diminutive trend in agricultural land areas, desire to increase food grain production might remain a wishful thinking. Food self-sufficiency of the 90s will be a forgotten achievement and food shortage will loom large. The target of second green revolution is 400 million tons of food grains as compared to about 214 million tons in 2006 and 7. The proposed time frame of 20 years to effect this revolution can be achieved only if we maintain 5 to 6% of growth rate in agriculture sector for next 15 years. What is then required to start a much needed second green revolution is to trigger a higher agriculture growth in India. Science and technology has to play a vital role by focusing on aspects like high productive genetically modified seeds to develop the per acreage production, private sector involvement, efficient marketing of ideas to bring awareness to adopt innovative measures, investment in long-stalled irrigation projects, linking of rivers to affect the water supply to the locations of deficit and parallel development. In the area of dairy farming with proper attention and respect to the ecosystem and the symbiotic existence of man, plant and animal kingdom. My dear friends, well, there is a lot more to discuss on technological leadership with regard to environment, biomedical, technology development pertaining to the improvement of the standards of living. Due to, of course, paucity of time, I do have to stop this address somewhere, and I consider it most appropriate to go back to where we began. Your empowered position as a graduate from Siddhiganga Institute of Technology and the responsibility that comes along with it to contribute to the nation with all your might. I feel duty bound to share with you my thoughts on relevant topic like this on this occasion, but I would be joyous if it has helped you in some way to understand the relevance of technology leadership for national development and security and identify your role in it. I have no doubt that you will always remain a proud alumnus of this great institution and dedicate a part of your time and resource to maintain the preeminence of your alma mater and bring glory to this institute and our great nation. May you have the satisfaction of contributing to society by employing your expertise. I once again offer my heartfelt wishes to all those who are receiving degrees today. May I cite a quotation from Mark Twain as my parting message. Always work like you don't need the money. Always love like you have never been hurt. Always sing like nobody is listening. Always live like it is heaven on earth. Again, my heartiest congratulations and best of luck. Thank you. Jai Hind.